Let's look at this example 4C5 together. In this example, we know a ball strikes the floor with speed v1, and this v1 has an angle v1 equals 9.18 degrees. That's this v1 here. And after impact of delta t, the speed is v2, and the angle of the speed v2 is v2 equals 150.82 degrees. That's v2. And so delta t is given as 0.001 seconds, and we know the weight of the ball is 1.3 pounds. And in this problem, we want to find out what is the average force vector by the floor during the impact. Okay, let's look at this example. We have a ball strike on the floor and it bounce back, and both V1 and V2 has an angle between the floor. Okay, then what's the T and N coordinate system for this problem? Number T, it's a plane of contact, and it's a line of impact. So this is how we just set up T and N. T as horizontal and as vertical. And once you have T and N set up, you can look at only at T direction, which is a horizontal direction, and what forces do we have? If we draw the free body diagram for the ball, for the forces, you're going to have impact force pointing upwards and the gravitational force pointing downwards, but we do not have any forces on the T direction, and that's we're gonna get sum of the forces on T direction equals 0, and we can use linear impulse momentum equation on T direction since the sum of the forces is 0. So that implies the conservation of momentum. Therefore 0 equals m times v2t minus v1t. As you see here, I use v2t and v1t to represent the velocities on t direction because we applied out linear impulse momentum only on t direction. But this equation doesn't tell us much, so we need to move on to the linear impulse momentum on n direction. If we look at n direction, that is a horizontal direction, and we do have two forces, wave force and the impact force, and the sum of the forces is going to be the difference between these two forces. That is not equal to 0, since the impact force will be much larger than the gravitational force. And we can apply linear impulse momentum equation on n direction, and on the left hand equation we have the integral of sum of the forces dt equals mass times v2n minus v1n. Both v2n, v1n are the velocities on n direction, which is the vertical direction. And v2n and v1n are not given directly, but we do know v1 and v2 as well as the phi1 and phi2. So we can project v1 to its n components, which going to be negative sine phi1, and the n components of v2 going to be v2 times sine phi2, which is positive. Then we can plug those velocity on n direction into our equation. We're going to have m times v2 sine phi minus negative v1 sine phi. And on the left hand of equation, since here we're trying to find what is the average force by the floor during the impact, So we can rewrite this integral as a average force times the period of time during impact, which is delta t. And since here this f average is something we're trying to find, so we can throw this delta t term to the other side of the equation, and we should able to get expression for average force in this case. Okay, so if you look at the expression here, we do know the mass of the ball, we given the weight, we know delta t, we know v2, we know v1, and you were able to plug in all the numerical values to solve what is the force.